This video will be on parametric equations. The three midterms that I suggested you look at all have, each of them have a parametric equations problem. So you know how to do these. We haven't done parametric equations for a long time. So I wanted to kind of review the general ideas. I mean, they all have solutions, but I know it can be hard to figure out what they did. So hopefully with me talking through it, it makes it easier to figure it out. Okay, so I'm going to do Pezzoli's number 3, which is Pezzoli 1/18 number 3. And you have x coordinate as a function of time, right, with t's in it, and y with t's in it. So where it is, it's x and y points at any time are given by t, by wherever what the time is, and t is greater than 0, so we're not dividing by 0 here, because otherwise obviously that would be a problem. Okay, they want to know, part A, what is a tangent line to this curve? If we were to graph this and let t go from 0, but not exactly 0, to whatever, what is this thing going to look like, the x and y points? They want to know the tangent line through that curve at the point 1, 2. This is x equals 1 at y equals 2. Okay, so when x equals 1, that must be either, let's see, so y is 2. When x equals 1, that means t must be 0, but t can't be 0, right? Because x would be t cubed plus 1, so t cubed must be 0 for x to be 1. But we said t can't be equal to 0. So this point is not on the curve, which makes it a lot harder. So we have a curve, like here's our curve over here, and then we have a point, and we got to figure out like the line, you know, tangent to that curve that goes through that. Oops, I missed. I'll erase that. Tangent to that curve, the tangent line of the curve that goes through some random point off the curve. And those are always harder. If the point's not on the curve, it's always harder to figure it out. So here's our point, 1, 2. And we'll call this point here the point that we want it at is some, let's call it A, B. That's usually what we call the point that we want. And so we want to find out that point, or the equation for the line, and to know the line we got to figure out that point. Okay, that's long story short. So first we need to know the slope. Okay, the slope of the curve. And the slope is, of course, dy dx. There's no t. There's no t in this. So what the formula that you need to know to do this is the same thing as dy dt divided by dx dt. You can imagine that dt's cancel, right? So basically we have a dy over dx because they both have a dt in the bottom, they cancel. But in this case we don't want them attached, so we want to actually take the derivative of y and the derivative of x with respect to time, put them on top of each other. So dx dt, we take the derivative of this with respect to time. That's just 3t squared. That's an easy derivative. Derivative of 1 is 0. This is 30t to the negative 2, right? Y is 30 times t to the negative 2. So that would be negative 2 times 30t to the negative 3, right? dy dt, so yeah, negative 2, take away 1 for the negative 2. Which, writing that again, 3t squared over, that's negative 60 in the bottom. We have t to the negative 3 in the bottom. So that's the same, and I just realized that I did this upside down. Okay, so I did this upside down. So if you're following this, you can erase this, and I did it, dx dt is in the bottom, right? dx dt is in the bottom. So dx dt is 3t squared. So that's 3t squared in the bottom. Okay, dy dt, I'm going to write this out to show my work. So that's d dt of y, which is 30 over t squared, which again is 30t to the minus 2. 30t to the minus 2. Okay, if you show all your work, you're less likely to make mistakes. That is negative 2 times 30, so negative 60, t to the negative 3 divided by 3t squared. Okay, that looks better. So negative 60 divided by 3 is negative 20. T to the negative 3 divided by t to the 2 is t to the negative 5. Negative 3 minus 2 is negative 5. So this is negative 20 times t to the negative 5. We could rewrite that as negative 20 over t to the 5th. This way is easier to think about, right? But this way is easier to do derivatives and stuff with. So I don't know. We'll keep it that way. That's what our dy dx is. That's the slope. At any time t, the slope of our graph is negative 20 over t to the 5th. Okay, that's step 1. Now we want to find, that's the slope of our curve, right? Here's some random curve that I drew. That the slope of the curve at any time is that. We want it to equal the slope of the line. So what's the slope of the line? The slope of the line is, right, so this is always a change in y divided by the change in x. Change in y is b minus 2. So b minus 2 divided by the change in x is a minus 1. But what is b and a? B is y. Y is 30 over t squared. So that's 30 over t squared minus 2. And a is x, and x is t cubed plus 1, so over t cubed plus 1. So that's our slope, which is, now we have two equations for the slope. And so we can set them equal and solve for what time do they have the same slope. Okay, so what time is it when they have the same slope? That's what we need to figure out. So again, the trick here is you get two ways to find the slope. Dy dx, taking the derivative of each one with respect to time and dividing them. And then just the regular old change in y over change in x, you know, drawing our picture, and you have 2 points. So we set those two things equal. This is the algebra part. So negative 20 over t to the 5th is equal to, big mess here, 30 over t squared minus 2 divided by t cubed plus 1. Okay, so now it's algebra time. What's the best way to simplify this? Let's see. I would maybe multiply this whole thing by t to the 5th. So, oh, sorry. This is t cubed plus 1 minus 1. Gosh, I keep making mistakes. Glad I caught that. B minus 2, y minus 2, x, t cubed plus 1 minus 1. That makes life a lot easier. It gets rid of the 1 in the bottom. Okay, so we have 30 over t squared minus 2 divided by just t cubed. Okay. Boy, I need you guys here to catch my mistakes. I'm glad I caught that one. That would have really messed me up. Okay, we're divided by t cubed now. Okay, let's multiply this whole thing by t to the 5th. This t to the 5th goes away. That gives us a t squared here because that cancels out. This cancels out 3 of them. So we have negative 20 on this side equals, we have t squared left times 30 over t squared minus 2. Well, this is looking good. Negative 20 equals t squareds cancel, 30 minus 2t squared. That's kind of nice. Again, times t to the 5th. In case you didn't catch that step, make sure I did it right. T to the 5ths cancel. Here, 3 of them cancel. We have t squared left. Yep, I did it right. Okay, let's put the 2t squared over here, the 20 over there. 2t squared equals 30 plus 20, so equals 50. T squared equals 25. And look at that, it's a nice square. So t equals plus or minus 5. We already said that t is greater than 0. Right, we're only worried about t greater than 0. So therefore it can't be the minus 1. So t has to be equal to plus 5. So at 5 seconds, they have the same slope. Okay, so now we're practically done. So what is x at t equals 5? What is y at t equals 5? That's then the coordinate of this point here, a and b, right? So when t equals 5, I'll do that over here so I can get one piece of paper. So when t equals 5, x is equal to 5 cubed plus 1. 5 times 5, 126, I guess. So x is equal to 126, and y is equal to 30 over 5 squared, so that's 30 over 25, 30 over 25, which we can reduce that, divide everything by 5, 6/5. Which, let's write that as 1 1/5 or 1.2. Just get rid of fractions. Okay, that is the point on our curve. This point AB is 126, 1.2. So what is the line between those 2 points? Sorry, you can read that now. We want to know the line between 126, 1.2 and 1, 2. So now we use our y minus y1 equals m times x minus x1. The slope at t equals 5, we could figure it out a couple different ways. We can, we already know the slope at t equals 5 is t equals 5. We have a formula for it. What's our easiest formula? We have this formula, we have this one. This is probably the easiest one, right? We could also do 2 minus, change in y over change in x, but we already have a formula here. So the slope at any time t is this. So t equals 5, m is equal to negative 20. There, now you can see as m is equal to negative 20 over t to the 5th, which is, t is 5, so negative 20 over 25, so negative 4/5. There's lots of ways to get the slope again. We could have just done it like, change in y over change in x. We should have gotten 4/5, but we already had a formula for it. And this formula is definitely easier than this formula. Okay, so let's choose a point. The point 1, 2 is certainly a lot friendlier. So y minus 2 equals the slope, negative 4/5, x minus 1, or y is equal to negative 4/5 x, plus 4/5, plus 4/5 plus 2, or finally y is equal to, and we can make that let's add those together. So negative 4, we can leave it as a fraction, so negative 4/5 x plus 4/5 plus 2/5. We could say that's 10/5, so 14/5. So plus 14/5, we could say that's 2 and 0.8 or something. Anyway, lots of ways to say that. But that is our line that goes through the point 1, 2 and is tangent to the curve. Okay, a lot of steps. They managed to do it in a lot fewer steps than the test, the solutions, but I think they should show more work. So, okay, hope that makes sense. And that's, of course, only part A. Now, part B says, suppose the parametric equations give the location of an object moving in a plane. Okay, they tell you the formula, but let's go over that. So for the velocity. So the velocity, how fast something is moving, is its derivative. The velocity, how fast it's moving in the x direction, Vx, is dx dt. Right, the derivative of how fast the x position changes, that's its x velocity. And Vy is dy dt, how fast the y position is changing. So the overall velocity, so this is the idea. Vx, let's say it's going this way. That's Vx, how fast it's going in the x direction. Vy, how fast it's going in the y direction. So if our particle is going over and up, what it's actually doing is going like this. Right? It's going over and up. So this is v. The total velocity is the hypotenuse. So v then is equal to the square root of vx squared plus vy squared, which, if we put the derivatives in, v is equal to the square root of dx dt squared plus dy dt squared. So this is another fundamental formula that you're going to use for all the parametric equations ones. Either you know this velocity formula, which again makes sense, it's easy to work out, or you need to know the slope formula, which is dy dt over dx dt. And they're always going to have something like this. Now we just take the square of the derivatives. We already took the derivatives. So dx dt was 3t squared, and that's squared, plus dy dt, and that was negative 60t to negative 3, and that's all squared. And they want to know this at t equals 1. So what is this at t equal 1? So the so that's what it is. So you can plug in t equals 1, take the square root. It's not so hard. They're really nice. They chose t equals 1. And so that's what the velocity would be, but that's not what they ask us. Okay, we could figure it out. Just plug in 1, square root of whatever. But what they want to know is the velocity increasing or decreasing? To do that, we got to know what the slope of the velocity is doing. Is the slope of the velocity positive or negative? So we got to take the second derivative. So, or the derivative of this. So we got to take the derivative of that thing. So you take d dt of the square root of, let's square this, 9t to the 4th. 60 squared is 636 with 2 zeros, 3600. T to the negative 3 squared is t to the negative 6, right? It's just multiply exponents, negative 6, yep, that's right. So we got to take the derivative of that, and then see at t equals 1, is it a positive number or a negative number? That's the idea there. If it's positive, it's increasing. If it's negative, it's decreasing. Okay, so let's do it. So derivative of any square root is 1/2 everything inside, 9t to the 4th, plus 3600 t to the negative 6 to the negative 1/2 times the derivative of what's inside. Okay, so 4, that's 36 t to the 3rd. 4 times 9 is 36. Take away 1. Yep, that's right. Negative 6 times 3600. Oh, that's a big thing. So 6 times 3600. That's 21,600. And negative, right? Negative 6, derivative of this, negative 6 times that. So it would be minus 21,600. T to the negative 7. I think that's right. Derivative of this, again, negative 6 times that. Take away 1, t to the negative 7. Okay, that's correct. That's our derivative. It's a mess. They're really nice. They gave us t equals 1. Okay, at t equal 1, all we want to know is it positive or negative. This part is always positive. Okay, square roots, this is a square root in the bottom, negative 1/2 means square in the bottom. Square roots are positive, 1/2 is positive. So really we just got to see if this is positive or negative at t equal 1. Well, t equals 1 is easy. T equal 1, that's just 36, minus a t equal 1. 1 to any power is 1, right? That's 1 over t to the 7th, and 1 over t to the 7th, which is 1 over 1 to the 7th, of course, is 1. So that's 36 minus 21,600, which is clearly less than 0. It's really far less than 0. So the rate of change of our velocity is less than 0. That means the velocity is decreasing. It's slowing down. So you would say the velocity is decreasing, so it's slowing down. And we justified our answer by taking the second derivative, by taking the derivative of the velocity. It's not really a second derivative, the derivative of our velocity. Okay, that's how these parametric equations things work. Two major formulas again, dx dt, dy dt, velocity is a square root of each one squared. And then the slope was this. And then just kind of going through and doing the derivatives really carefully. Remember, there are always two ways to find the slope: from the definition, change in y over change in x, and from the derivative, set them equal, find the time, all that kind of stuff. Okay, hope that makes sense. Try these on your own. Try working the other ones. Every single midterm had a parametric equations on it. That means your midterm will have parametric equations on it. So hopefully you can work on these and make sure they make sense. Thanks for listening.